quadratic models. So quadratic models are equations that show a relationship between variables in the shape of a parabola. So parabola is going to look something like this. Where if the parabola is, it could be shaped like that, or it could be shaped like this. And if it's shaped like this first one here, we call this a maximum turning point. Because that value for y up there is the maximum value that you can have on your graph. Over here, you probably guessed it, that's a minimum turning point. Because there is no value lower than this one on the graph for your y values. Let's have a look at an example. So we've got a model rocket is launched into the air. The relationship between its height and the time can be described like this. H equals minus 5t squared. So it's a relationship between height and time, plus 100t, where h is in meters and t is in seconds. Now, first thing we want to do is plot out this relationship on a graph, and to do that we can just use a table of values. So let's go t and h, make a little table. And we'll pick out like 0, 5, 10, 15, and 20. Okay, so always what you want to do, you always, whatever the variable is on this side in your equation, is you want to be at the top, and you want whatever the subject is to be at the bottom like that. So let's go ahead and fill this table in now with some values. So when we sub t is 0 in, we get 0 squared is 0, times minus 5 is 0, plus 100 times 0 is 0, so we just get 0 for that one. Now if we put in 5, we're going to get 5 squared, maybe we'll write this one out, where minus 5 times 5 squared plus 100 times 5, so we're going to get 5 squared is 25 times minus 5 plus 100 times 5 is 500. That's going to give us minus 125 plus 500, so we should get 375. And repeating the process, if you sub in 10, you're going to get 500. If you sub in 15, you're going to get 375. And if you sub in 20, you're actually going to get 0. So what's this all look like? Let's plot it out and have a look. Let's go 100, 200, 300, 400, and 500. And let's go 0, 5, 10, 15, 20. Let's do some plotting. So we've got 0, 0, which is over there. We've got 5, 375, which might be about there. We've got 10, 500, which might be about there. 15, 375, which is about there. And 20 and 0, which is about there. And hopefully you can see that, yeah, that does form a parabola with a maximum turning point. So let's answer a few questions. So what's the maximum height that the rocket reaches? Well, hopefully you can see from the graph that's going to occur at the maximum turning point, and that's going to be 500 meters. This is your height, in meters, and this is your time in seconds. That's a label my axis there. And when does the maximum height occur? Well, we can follow that down to our time. and that's going to happen at the 10-second mark. Alright, so when does it get back to the ground? Well, if you follow the story here, we start on the ground and we go up to 375 meters, up to 500, and here we start falling back down and we get back to the ground at the 20-second mark. And what are the limitations of this equation? It's an interesting question. Now, the limitations of this equation, well, technically I can sub in any value for t, and it would give me an answer for h, but a lot of those values of t are not going to make any sense. If I sub in t equals -1, for example, over here, I'm going to get a negative value for h. That's not going to make any sense. So that means that t has to be at least be 0. And you can see anything beyond t is 20 is also going to give negative values for h. So that's not going to work either. So our limitations for the equation is that t has to be in between 0 and 20.